Hi Year 10. So this is the second lesson of the section on developments in new materials. So can you all turn to this page in your booklet where it says Smart Materials at the top and write down the learning objective, which is I will look at smart materials to see how new developments could be used in design. Fantastic. So you will have written down the learning objective by now, and we're going to look at three smart materials that are commonly used in manufacture today for different products, and they're used for their very specific properties. So to begin with, what are smart materials? We've got that keyword at the top of the page. Smart materials are materials that changes their properties in response to changes in the environment. So it changes their properties, it changes specific parts about them or how they react to changes in the environment. By that, it could be changes in temperature, changes in heat, changes in light levels. So the first one we're going to look at are thermochromic pigments. So thermo, that first part of that, the smart material, thermo, what does that mean? What does that tell us? What does that make us think about? So for me, thermo instinctively makes me think of heat, of like warm clothing, thermos flasks to keep things warm. So thermochromic pigments, the definition which I want you to write down is that they are materials that change colour in response to changes in temperature. So if you ever forget, think about the beginning part of this word, thermo, which relates to heat. Therefore, it changes its colour in response to changes in temperature. Get that definition down on your page. We've got several uses for thermochromic pigments. So the GIF at the top left of the page is a good example, novelty mugs. So when you pour a hot beverage, if you're making a tea or coffee, into a mug that uses thermochromic pigments for design around the mug, when the hot liquid is poured into the mug, it will heat up and the colour will change dependent on what the design is. So it's a good branding opportunity and it's a good selling point for different products. Also used for drinks bottles, so on lots of thermos flasks, so like drinks bottles that are meant to retain heat. It will have a thermochromic pigment. Some of them have like a little strip along the side, which will show you when you fill up the bottle for the first time with hot liquid and put the top on, it will fill the whole bar up with red, and then as the day goes on and it cools down, the colour will slowly fall down like a thermometer. And it's also used for children's thermometers. So you know those like plasticky little strips where you place on the child's forehead and then it starts to show different bars of heat, of red, to show you how hot the child is on their forehead. So pause the video here, make sure you've got all of that information down. And our next one, test strips on batteries. Forgot I popped that one in. So make sure you've got that one down, and then let's move on. Lovely. So the next one, photochromic. Photos. How are photos made? Photos are made by capturing an image onto a strip, old school film cameras are used by exposing a film to colour, and that will imprint the image onto it. So photo is talking about light. So the definition for photochromic pigments are that they are materials that changes colour in response to changes in light levels. So the lighter it is, the darker the pigment gets, the darker it is, the more transparent or lighter the pigment gets. So a common use for photochromic pigments are UV wristbands. So they're like rubbery wristbands that go around your wrist, so that when you're on holiday you can see how much UV you have is being exposed to you at that time. So if it's very high up on the meter on your wristband, you would put more sun lotion on. If it's very low, then you won't need to reapply as often. So it's a good indicator for that. But one of the most common uses for photochromic pigments are transitions lenses for reading glasses. So which means that you don't have people with glasses, you probably get into that trap where you have to have one pair of glasses for reading, and then you have to have a separate prescription set of glasses for sunglasses. So transition lenses actually combine those two together, so that if it's not very bright, if there's not a lot of sun out, then the lenses will be completely transparent, so you can see through them perfectly. But as the light levels increase, as it gets brighter throughout the day, your lenses will start shading over, so to block some of that light so that you don't get sun damage in your eyes. So pause the video here, get all of that information down, and then we will move on. Awesome, so our final smart material is our shape memory alloys. So shape memory alloys are a type of metal, and it is a material that can be bent or deformed, so it can be crushed into different shapes, but will return to their original shape when heated. So it's materials that can be stretched, bent, forced into different shapes, but with heat it will start returning to its original shape. So common uses are for hot water valves in showers. So as hot water starts passing through the pipes, the valve will start to open up with that added heat to allow the hot water through. But when you're using the cold tap, it will cool down the metal, so it will go back into its original shape. Foldable glasses. So there are glasses where you can literally just crush the whole thing, the whole frame, and scrunch them up and put them in your pocket, and then when you take them out, they will fold back out into their original shape so that you can use them. But probably the most common use, and the use which you can see it in action the easiest, are braces. So braces for our teeth. So when braces are implanted, the metal wire is a shape memory alloy. So when you've got the little the holders on each of your teeth, they're going to be bent. The dentist has to bend the wire to attach onto all of those holders. But then when it's installed on your teeth, the heat from your body, the natural heat within your mouth, will start acting on the shape memory alloy, and those metal wires will start trying to form back into a straight line. So that's why they slowly pull this teeth down back into place, so they're all perfectly matched up. Pause the video here, make sure you've got all of that information before moving on. Fantastic. So we've got 3 smart materials, 3 definitions. The materials on the left, definitions on the right. What I'd like you to do is try to match the specific smart materials on the left to the correct definitions on the right. Pause the video here, try to match them together, and then press play when you think you've got it. Okay, so thermochromic pigments. Are they materials that change colour in response to changes in temperature? Materials that change colour in response to changes in light levels, or materials that can be bent, deformed, and will return to their shape when heated. If you said that they are materials that change colour in response to changes in temperature, you are correct. Shape memory alloys, which one is it? Is it the second option or the third option? Say it to the screen now. If you said the third option, you are right. They are materials that can be bent or deformed and will return to their shape when heated. That leaves photochromic pigments, that are materials that change colour in response to changes in light levels. Next, we've got the specific smart materials on the left, but on the right we've now got images of products for the specific smart materials. Pause the video here, try and match them together, use your knowledge. Okay, so thermochromic pigments, is it the sunglasses, is it the mug, or is it the braces? Say it to the screen in 3, 2, 1. It's the mugs. Shape memory alloys, is it the sunglasses or is it the braces? 3, 2, 1. It's the braces. So that leaves photochromic pigments. They are used for transitions lenses. To the screen, what you think the definition for thermochromic pigments is. If you said that they are materials that changes colour in response to changes in temperature, you are correct. Next one, shape memory alloys. Say the definition to the screen without using a booklet. If you said they are materials that can be bent or deformed and will return to their original shape when heated, you are correct. And finally, photochromic pigments. Say your definition to the screen now. If you said materials that change colour in response to changes in light levels, you are correct. Final one now, we've got our 3 definitions. We need to figure out which smart material each definition is matched to, but I haven't given you the names for each one. So take 30 seconds to a minute now. Try to remember the specific smart material names for their specific definitions. Go. Okay, let's go through the answers. So the first one, materials that can be bent or deformed and will return to their shape when heated. If you said shape memory alloys, you are correct. Second one, materials that change colour in response to changes in temperature. If you said thermochromic pigments, you are correct. And finally, materials that change colour in response to changes in light levels. If you said photochromic pigments, you are correct. Okay guys, that is the end of this lesson. So please make sure that you have got all of the information in your booklets, because that is going to be your best revision resource. And I look forward to seeing you next time. Thank you guys. Goodbye.